I like to introduce example 1.5, but I think it might take too much time. You don't have too much. I want you to get whatever you already learned already in hands. So let's look at example 3 again. Example 1.2. But this time I want you to do the calculation straight away. So let's look at the example. And based on the theory I just mentioned, the probability theory. Previously I try not to mention probability, but now probably have to mention a little bit probability. Okay. So the most probable value I told you already. I told you guys already. Basically, we are going to get this one. Based on this one, you go to have the statistics of this. Have we can call it mean statistics. Mean statistics basically to guess the value of the most probable value. It represent the value of the most probable value. So we could use mean statistics. Use this one, mean statistics. So you have a distribution of this one. Once you have distribution, this have a distribution. So this one you have a mean. This mean will become the probability of a most probable value of this one. And also you have a standard error. This is a weighting mean. This is a weighting mean. We'll calculate weighting mean. So this one will have a weight. Weight as well. Weighting mean. We call weighting mean. And the other we can get rid of this one. We don't care about this one. So we don't introduce. Otherwise we'll confuse you. So we care about A. And also if we want to calculate D, there are two approaches. But many now probably we don't do I have to introduce? Maybe I have to introduce B as well. A, B, and D. Okay, let's focus on this one. Again, if you don't know how to do it. So this is the last chance. We won't repeat again. Otherwise, you have to look the book by yourself. If you can understand, you have to just look at the book by yourself. Okay, so let's look at this one. So you are measuring the angle. Make it much more real. It made 86. So this is your angle. Okay, this is your P point. This is your Q point. You are going to measure the angle between OP and OQ. This is your, let's say this is your C, or maybe okay C. So you are going to measure the angle between CP and CQ. Okay, this is okay. So how many times do you measure? You measure 1, 2. There are many ways to do this kind of interpretation. First way is you treat it as like one person that do everything, but at different days. So at some days the weather is good. So the measure is much more trustworthy. So you put a weight is 3, 4 is high. You can treat like this one, like one person by measure that come back and then the very next day come back and so on and so forth. And if the weather is good, it's much more accurate. So he put the weight. If the weather is bad, so the accuracy is low or something like that. Or you may treat like a different kind of machine. This machine is very precise and accurate. If you put a higher weight, it's much more trustworthy. With the machine, even you use a naked eye or something, or machine is a lousy one, cheaper one. So it become you put a weight one over here, something like that. So this just a data. It might be different, comes from different background. But anyway, it just give you some kind of weight. Okay. So each one of them, you treat like the data come from all of them. Every of them come from some kind of called distribution. Before I do the angle, I don't know the angle. I just look at it, but I have no idea the angle between CP and the CQ. I have no idea. So basically, they are distribution. Before you do anything, they are distribution. This might be their distribution. The probability, the number of this one. Of course. Anyway. So once you have a distribution, you assume the distribution, whether you have a distribution or not. In principle, not, but you are going to do the statistics. So basically, you assume yes. So now we are going to do the distribution of this one. And if the very next day you think there is no huge difference between every condition, you might treat this the condition is the same. So you might based on this distribution and do the second drawing. But the condition change a little bit. You have to have specified different x1, x2 random variable. You have if the condition doesn't change too much, the very next day you treat your population is the same, just like this distribution. You do a sampling and so on and so forth. Third day depends on whether your condition change or not. And this weight just like I say, how much trust you put on it. High weight, it means you have a higher trust on this one. Okay, so now based on this data, you get all this one, right? You get all this one. How are we going to get because you are going to provide the data to your client. Your client asks me, what's the angle between CP and CQ exactly? So there is no exactly. Exactly means there is a value plus some error. So you have to tell your client, tell your client, the most probable value, most of the time, the most probable value is how much, and then the error, based on the statistic, the error might be this one. You have to give this information to your client. So we are going to calculate this information. Okay. So chapter 1, at least you got to do how to do the calculation like this one. I will repeat this kind of situation again, because some of you too complicated, you cannot get it, but this one is easier for you to understand. Okay, so first of all, we are going to calculate something called weighted mean. Most probably is a weighted mean. Weighted mean is also a statistic. Weighted mean is also a statistic. Weighted mean. Okay, so you put a different kind of weight, different kind of on the whole situation. So the random variable, this random variable will look like this one. Like previously, random variable was like this one, like xi is a different kind of random variable. You don't know distribution divided by n. You got this one, right? This is your random variable. Previously, that was this one. And then now it changed. It changed because you give a different weight for different random variable. So, and if you get a different weight for different variable, it means you assume the distribution already changed. So in this case, you put a weight over here 1 and then 3. It means x2 changed already. Or change 2 is not equals s1. Change already. It changed already. You assume the change already. Okay. So. Based on this one, you will get this one. Because weight 1, weight is 1. Now I put a real number, concrete number. Otherwise, you don't know how to do the calculation. And x1 is a random variable. So 1 is known. 1 is 1. Number 1 we know 1. S1 unknown. S1 is a distribution. Plus 3 known. I already put away. But the second one is a distribution. I don't know. The second one distribution. I don't know. And so on and so forth. So keep on doing. Now this is called statistics. Before you do any calculation, itself is a distribution. It's unknown. The distribution is unknown. Even although it's a mean, yes, this mean is unknown. That's a reason. Because why this mean? If you already know the distribution, the mean won't be unknown. The mean will be exactly. But since it's a distribution, so the mean is also a distribution. Also a distribution. Okay, so why? Because you might get one number over here, another one number over here, and so on and so forth. So that if you average them out, there will be different number. So it depends on different position. So. Okay, so keep on doing 1 and till the last one. You have how many of them? You have like 1, 2, 3, 4, 5, 6, 7, 8. In total, you have 8. A number is 8. So you have x1. You assume x1 up to x8. These are random number. So basically, all these numbers come from some distribution. There are 8 different kind of distribution. Because you give them different kind of weight, you assume they already have a different distribution. That's the assumption. Last time we talked a little bit. Anyway, the x2 is x2, and x3, so on and so forth. And the last one is 3 times x8. Okay, and then you average it out. It depends on weight. So in total, the weight, weight, you have how many weight? You have like 1 plus 3 plus 1 plus 2. In total, the weight is how much? 18. 18. So you divide by 18. And this one itself, this one by itself is a random variable. What that mean? It means this one by itself is also a random variable. We might look at this one. This might look like S bar. Since it's a random variable, this one itself also have we call the mean and the variance. So now we are going to calculate the mean and variance. That's the basic idea. Okay. So how are you going to get the weighted mean? The weighted mean over here. The weighted mean. Weighted mean is you just all the number. Just the first number, second number. So this one will become the realization of this one. In our notation, this one will look at this one. The first section I just mentioned, use this one. Right? It's real. To sense is a realization. So basically, this is a realization of this one. This here is a distribution of function. This here is a realization. You get some point because they are realized already. S1 up to S10 already. You realize 1 point. Realize S1. So this one is normally is written small capital X1. But here I use S1, the random variable, realization of this one. This is a realization of a second random variable. Second random variable. Okay, and so on and so forth. Realization. Alright. Once they are realized, this one will also be realized. Because if this one realized, this one realized, everyone realized, then you also have a relation of this one. So you get a realization of this one. So basically, this realization of this one, this just means it's 1 point, 1 more point. This is 1 point. Okay. If you are lucky, this point might be in the center, in the mass, exactly the center. If you are a bit unlucky, then this one might be a bit extreme. So not every measurement is accurate. Some you still have some kind of like a mistake. But the more data, the more times that you measure, the more accurate you can get. That's promised by statistics. Okay, so there is no problem. The most probable value you get already. Most probable value is this one. You already get it. Now comes to the second problem. How are you going to stand? So what's the meaning of this most probable value? Easy. The most probable value just like a name appear. Most probable value is just most likely to happen. Most likely to happen is this value 86.7. This value based on this point is most likely to happen based on the background still statistics. Okay, let's come to the last one. Last one, going to calculate the standard error or mean. This one, standard error or mean. Previously, that was standard error. You don't have a weighted mean. So this one already changed a little bit. Is a weight. So maybe if you like, I can put a weight over here. And like previously just this one. We tend to use this one as a notation. X bar. But this one you put weight. I have different weight. So you put X bar weight. They are pretty much the same idea, but different weight. All this one weight is 111. I put all the weight be 1. So it'll become this one. So this is an extreme case. All the weight being put even, it become extreme case. The general case will be this one. More general case. So weighted one is much more than is because of this one. Okay, so now what are you going to calculate? You are going to calculate standard error. And based on the statistics, of course you have to go statistics. But now I don't know how much you can take for statistics. If you can't take it, you can just memorize this one and do all the calculation. And in the sheet I gave you guys, I also this one I also derive and give you some idea about the weight over here. And your mean, your variance, and the variance will look like this one. Your variance will look like this one. So I already give you some hint over there, but I also prove them as well. So and if you need any proof, just let me know. I also do have proof, but hopefully in the long run, you understand this one. If you really cannot understand probability bit, at least you should know how to do the mechanic to operation as well. At least you should know how to do the calculation. Okay, now let's go back how to do this calculation. So this is the you don't have to care about this one. You forget about this one, huh? You focus only about this one. This is the calculation. So this is your formula. This formula you have to go to the derivation. So basically, it's not too hard to understand how to do the calculation. Basically, you just this is the summation of all your weight, summation all your weight, and n is your observation. In this case, you have 8 observation. Minus 1 is 7 over here. Weight is 18 over here, and this is your weighting error. And by the way, this is not correct. This is not correct. This is supposed to be omega. In the omega I, not omega, but this book is a bit lazy. I tend to do. This is omega v squared. Omega v squared. Now you look at the original. Original is omega v squared. No, it's the omega times v squared. So get rid of this one. There are many mistakes in this book. So that's the reason I have to prove by myself. So the result I got is this one. So trust me. So this is omega times v squared, not omega squared. Okay. So if you don't believe me, you can check the solution as well. So you now v is your error. V is your error. Basically, v, every v is the we call vi, not v, because here this if I write a book, I don't write this way. Basically, I tend to write something much more precise. So this is the yi is your observation. Y is your the random variable of I random variable minus the y. So before you do the realization, this also is also statistic. Also distribution, and now is not distribution, and now is realization. So this is realization. Realization. So in order to get this realization, you can have observation and also the mean of all the observation as well. So this is a realization, because now you are calculating based on sample. So this is supposed to be like sample standard error. So basically, it's also a statistic. And this statistic will approximate the we call the population standard error. So if you use this statistic, you approximate the real one. I use this one, statistical approximate. I mean mean-wise, you will approximate another one. Okay. Whether you understand or not, it doesn't matter. But at least you know how to do the calculation. That's this requirement. Okay, so how are you going to do the calculation? This is your y1 realization of your y1. Or previously I use x1. x1. This is your x1, your random variable of x1. Right? This is your random variable x2. Based on x2. And you have a realization. This number is your realization. This number is your realization. So if I use a break, it means it's already realized. It's already a real number. Without breaking, they are a function. Once you use breaking, they are number. Okay. So x1 up to xn, they are already realized. So now this is a v. V, you have to realize them as well. How are you going to calculate a v? You calculate the mean first. So this is your mean. This is your mean. So basically, this is just If you use our, it's just the realization of this one. You have a weight. This mean is a weight mean, weighted mean. So this is a realization of 26. A realization of this one. Okay, so now what you're gonna do is you look at this one. This is x is your observation. So this is x1. Realize not this one is this one, this one. So he just extract this part as your x, because you also in this part you all have the same like a second and the degree. So this part you don't consider about this part. If you do the weighting mean, if you put that inside, it's okay, but the solution will be the same. So in order not to be simplify things a little bit, you just take the last bit, the second bit. So it's a 25 second, 28 second, 22 second, and so on and so forth. And then you wait. We already have a weight over there. The weight are given. These have a weight over here. The weight are given already. And then you have omega times x. Omega times x is your this is your mean value, because we are going to calculate the mean. So you have omega x. Indeed, omega I xi. Omega I. Here indeed you have use anyway omega, and then this is omega I as well. Okay. We can't stop it. This is omega. Okay, so now you add them up, will become this one 400, and this one will become 467. 467, and the weight is 18. Weight is 18. So let me see. This is your x. X is your this is your 208. So 26. This is not our weighting mean. This one just the this one is not weighting mean. The weighting mean will be this one. The weighting mean will be this one. So in principle, you have to minus the weighting mean. Let me take a look at this one. So I see. We haven't derived the everything. Because if you derive it, you'll find out the value look like this one. Because I'm just calculating the weighting mean. But let me see. The weighting mean will be this one. Will be this one. Take a look at this one. This is your weighting mean, right? You have something like you get the left hand side. Left hand side you just get rid of them. So you don't do the calculation weighted. I don't put the weight. You can put them into a weighted. They're still the same. So this one you just they are the same. But if you want a number change, you have to put them into consideration as well. So this one will become this one, and this bit is your weighting mean. This is weighting mean. So put over here. This is weighting mean. Okay. So now comes to the standard deviation. Basically, you now have you put this one aside. Put this one aside. Now it comes to the estimation. Estimation basically is still based on the. This is not weighting mean. Based on this one. This is not weighting mean. It's just do the mean. In total you have 8. So this one is this one divide 8. So this is the typical mean. And this is because by the proof, by the proof. Indeed, because it might confuse a little bit like this one. Because this one is your weighting mean. This one is your weighting mean, right? But this one have no weight. The weight are all the same. They are evenly spread. So this but why? How come you use these numbers to do your by principle? Use this number. Use this number to calculate your standard deviation. But how come this one? Because we call something called statistic. We haven't derived a statistic for you guys, but just take for granted. So in some sense, when you calculate the weighting mean, you calculate this one. But when you get a standard error, you don't use its weighting mean. You use its mean. It's a normal mean. Let's call this a normal mean. Okay, so in this case, is 26. So this mean will be 26. This mean will be 26. You will become the V. V is a arrow between xi observation and minus x bar. Here you can see it's not weighted bar. You just use 26 your x bar by derivation. So standard error and the mean value, they are calculated using different mean value. That'll be focused. Okay, so in this case, I have 26, and then the standard error is realization 26. So 25, here is a different direction. It doesn't matter because they will be squared. But we just follow this author's approach. He put the s square in the very beginning and put xi in the end. Okay, so this will be 26 minus 25. So this number comes from 26 minus 25. If you get one number correct, later on you can do the same thing as well. So this v will be plus 1 because 26 minus 25. And then this number 26 minus 28 will become x bar minus x2. X bar minus x2 will be this one. So it's minus 2 over here. So on so forth, keep on doing. You'll get all the number. And then, because in the derivation, in the formula, you have to type omega times vi. Omega times vi. So omega is here, is the weight. Omega times v squared. So you have the square of that. Squared. So 1 times 1 square is 1. 3 times minus 2 square is 4 times 3 is 12. So it's square of that. And then adding up. You have to add up. If you add up, that will become 93. If then adding up, it will become 93. So this number will become 93. Your number will become 93. And then divided by what? Divided by using this formula. Divided by m minus 1 times omega. M is a minus 1. So in total, this one will get this one. This is your standard error of weighted mean. So in the end, you have to write solution like this one. The solution will be written like 86 degree 47 minute 25.9 second plus minus. So this is your final solution. Plus minus this one. 0.86 second. This is your final solution. 0.86 second. Okay. So this is the whole thing. So we run out of time. So let me remind you one thing. First of all, we care about the most probable value, most likely, most probably basically, and the plus minus is a standard error. But since here we have mean, so this probability is a weighted mean. This is a weighted mean. This is your weighted mean. And this standard error, in principle, this standard is related to this this mean as well, this probability mean. But based on the derivation statistics, indeed you can get rid of everything. It become the normal one, the way you treat the normal mean. So you just calculate the mean. The normal mean is 26. You don't use this number. You don't use this number. You use this number. So you don't put you don't add like 25 times 1 blah 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 and then divided by 18. You don't use this number. You treat otherwise you have some mistake. Is the statistic will be changed. So this standard error and this one standard error mean will based on the normal mean. So how to do the calculation? I told you guys already. You do the this bit. You do this bit mv square. So just follow suit. So now let me talk about your homework. Your homework is easy. Just reproduce this one. Reproduce this one. Because and we'll call it let me see. I'll consider about it. Maybe next time we'll talk about a little bit about weight, but maybe not. We'll talk about it. But definitely, we won't come back to this kind of example again. At least for this kind of example. So this will be your final solution. MPV over here. Your final solution. So MPV is this one, 86 something over here. This is your MPV. Plus minus your standard error mean. The standard of your weighting mean will be this one. 86 according to this one. Okay, so I write it already over here, but now you have to use your calculator and your machine to reproduce this number, and that's it. I basically that's it. In particular, you can do in other ways you to check they're correct and write down on your paper. I write down on your paper. And any question? Okay, any question? It's we can't keep on saying we have to. But this kind of example will be used again and again because later on we are real measurement. You really need to measure some data and get some angle, and we give you put some weight different kind of machine, different weight as well. And this weight might come from the standard deviation. So there are many ways to get this weight as well. So it can be subjective, it can be objective. So we will also come to this weight and then as well. Okay, any problem regarding homework? Regarding remember this you're supposed to be able to do this. I just ask you to recheck then. So there is no problem. Like I don't know. I just told you a bit by bit already. So you just follow suit, and of course a lot of probability theory behind all this kind of thing. But we can't go through probability a lot because we are not talking about probability. I'll just use probability to do this bit. So if you have some other problem or you want to know more, let me know. I can send you the derivation, everything. I can even send you the book or something to teach you more. But if you think it's enough, I just want to know how to do the calculation. Fine. Just follow suit and then know a little bit about statistics and then follow suit how to do the calculation, and then it will be fine. We focus on how to operate rather than how to know all the theory. The operation is the paramount importance in this subject. You got to know how to do the operation. We don't rely on theory too much. Of course, if you are interested in theory, it's good. You can focus on theory. If you anything you don't understand, you want to delve into more things, you can let me know. I can help you a little bit. Okay, that's it. Probably you have to call it. I have another lecture to go, and then we see on Wednesday. And please submit this homework by Wednesday because it's an easy one. Just do the check-in. And Wednesday, maybe I'll go to the next chapter. Maybe I'll focus on weight. Depends. We'll see. But any feedback or anything, let me know. You can do weight chat or something. Let me know the feedback because online thing is already quite painful. The progress is slow, and we don't know how your response. I can't see your face expression. I can't actually do the campus exercise as well because it takes too much time. So a lot of painful stuff. But that's the typical one. Like the previous I told you guys already, that this might become the main this term because I calculate the timing already, so you already know this will become the okay. So participation, homework, and maybe essay. So focus on this one and learn more. We will easily tell whether you are learning things or not. Okay, let's call it a day. Any problem? Okay, if not, I just let the class monitor take over, and then we shall see on Wednesday. And if any part you still no idea on how to do it, let me know. Just don't keep it in your mind or keep it into your chest. It doesn't help. You gotta let me know. And all I can say is I need feedback as well because I keep on talking, but I don't know your progress or anything. So if any problem, give me some feedback, and I will try to help you guys. Otherwise, you will keep on going. Okay, if no problem, see you next time.